Hi, everyone, and welcome to our Constellation Crew program this evening. I'm Dana Thompson, Planetarium Director here at Ball State University's Planetarium, and I'm joined with some of the members of the Constellation Crew. We have Melanie on camera here. Hi, Melanie.
Hi.
Nicolette. Hi, Nicolette. And we have Caleb. Hi, Caleb. And if you watched
Hey.
us last semester, then you all remember Melanie, Nicolette, and Caleb. We also had Alec and Ricky, two graduate students, helping us out here. And this semester, they've gotten reassigned to some other really interesting projects in our Department of Physics and Astronomy. So we have a new graduate student helping us out this year. We have Greg, and he's going to be looking at the chat and helping everyone in the chat. So if you have any questions or answers to our questions during the presentation, just put them in the chat and we'll get you settled there. So we're focusing on constellations during our Constellation Crew programs. We're going to be focusing on one this evening, and it is up on the screen. It's up, let's go back just a little bit, and here we go. So it is visible on our screen right now. It is probably the easiest constellation for many people to find in the sky, and that is the constellation Orion the Hunter. So you can go outside tonight after sunset. If the weather's nice, you can see Orion the Hunter all night long in the southern sky. Well, how do we find Orion? So if you're not familiar with Orion, or if you can only find part of the constellation, what do you want to look for? Well, there are some things to help you find Orion the Hunter in your sky, and Melanie's going to help me explain what to look for. So Orion is a hunter. He's kind of like a stick figure guy. And Melanie, there's this belt that's a part of Orion, right?
Yep.
So
it's definitely the easiest thing to find. I usually just look for 3 stars that are basically equidistant from each other with about the same brightness. So I'll give you a chance to look for them.
Yeah, so look for 3 stars in a row that might make up the belt of this constellation that we're finding Orion the Hunter. All right, so if you have seen them, they're right here in our picture. This is a real photo of the night sky. And there's 1, 2, 3 stars in the row here for his belt, and that makes up Orion's belt. I have had people tell me that they can only find Orion's belt. They can't find Orion, but they can find the belt. That's a really good start. But there's more to this constellation. So it's a stick figure guy. So instead of just a belt, there are 2 stars that make up his shoulders and 2 stars that make up his feet or his knees, depending on how you draw him. And so if this is his belt right here, and he's right side up here in the northern hemisphere anyway, then he's got 2 stars up here that make up his shoulders. So you can see these 2 right here. Those are his shoulder stars. And then below his belt here are going to be his feet or his knees, depending on how you draw him, down here. And there's a little bit more going on. So off of the belt here, there's this string of stars or star-like objects that make up his sword. So if you put that all together, you should be able to see Orion the Hunter right here in our field of view. And you can see Orion after sunset in the southern sky. And if you look closely in this photo, especially, you can see some color. Like this star definitely looks like a different color than this star over here, right? This star right here looks a little reddish, and this one not so much. In your sky, you're going to see that too, but remember, this is a photo. So when you're taking a picture, especially of the sky, you can take a lot of light in at a time and take what's called a long exposure image, and it gathers all that light and it starts to show more detail than what our eyes can actually see. So we can see a little bit more color in some of the photos that we take of space, like this one. All right, so I mentioned that there's this string of stars and star-like objects that make up the sword. There's actually a lot more going on in that location, and Nicolette's going to help us with that one.
Yeah, so we are going to talk about the Orion Nebula. It's also called the Great Nebula, or to put them both together, the Great Orion Nebula. Take your pick. All 3 of them are perfectly acceptable. I'm going to go with the Orion Nebula because it's easier for me. But we're going to look for those 3 stars again and go down to the sword, and you'll start to see as it zooms in this really fuzzy thing. It appears like a star down here on Earth, a point of light, or if you have very little light pollution, it will look slightly fuzzy. This is the Orion Nebula, and it's actually very fascinating. It's one of the brightest nebulas that we can see in the night sky with our naked eye. If you want to get more detail, of course, you'll need a telescope, or a pair of binoculars also work just as good. The nebula itself is 24 light years across. It is very large.
All right, so this area here that we just zoomed in on, this is a kind of an overall picture of it, a really good picture. What did you say? That's 26 light years across?
24.
Okay, 24 light years across. And Greg's helping us out, putting out some definitions of some of the terms that we are going to be using during our programs. And so he explained what constellations are in the chat, but we also have been using this term called light year, and it's a distance measurement. It's the distance light travels in 1 year. It's about 6 trillion miles. So for this to be 24 light years across, and every one of those 24 light years is 6 trillion miles, that's an amazing amount of space. You can have so many solar systems, a little part of the space that we're a part of here on Earth in this area.
It boggles my mind sometimes. I prefer the light years because of the trillions of miles, just a really big number.
It is a huge number, yeah. And trillions doesn't, like, it's even hard to comprehend what trillions means, but we're going to try to explain what that means compared to numbers we can kind of relate to in everyday life a little bit later in the program.
So as we zoom in, we're going to see a lot of different stuff going on. This is a very important nebula in the astronomy community because there's so much astronomical activity going on in here, such as protoplanetary disks, which is a disk of gas and dust around a very young star. It is theorized to be a host for planet formation. But there's other stuff that astronomers have seen and cited here as well, so feel free to do your own research about that later on. We're going to zoom in a little bit on all these stars. This is the Orion Nebula cluster. It is made up of 2,800 stars and is 20 light years across. So the majority of its distance is the open cluster itself, which is actually really cool. And inside is a smaller cluster. They call it an open cluster. I would just call it a cute little group of stars called the trapezium. It's 4 of them, and they form a trapezoid because of the trapezium part.
We just flew by, like, okay, so there's these like really bright large stars, probably were created in this cloud of gas and dust, this nebula. And there's other things being created in here too. We just flew by this weird looking tadpole thing. Let me see if I can go back and try to find it. Oh, there it is. Do you see it on screen here?
Oh yeah, I see it.
This little guy here. This is actually a star being born here too, but it's surrounded by this really thick disk of gas and dust that's blocking out the starlight. And so this is actually, scientists have seen real images of this. This is a simulation right now. We haven't actually flown anything through the Great Orion Nebula, but we have really good information from observing it with our really good telescopes here on Earth. And they've been able to see things like this in this area of space. And they know that that's actually a solar system, or really a star system being born there. So that's what that was, just to back up really quick. So there's these stars being formed here. There are stars that have been around a little bit longer, that are emitting this light that really makes this cloud of gas and dust glow quite a bit here. It's very colorful too.
Looks like cotton candy.
It is like cotton candy.
Looks very cozy. I would live there if I wouldn't die in space. Maybe.
looks like maybe like a big shake or something, like ice cream.
Well, there
Like
you go.
oh,
Sure.
like, you know, like a frappuccino, that rainbow unicorn one.
Yeah.
Oh.
The unicorn drinks. It's a big thing now. But yeah, like there's actual color. It's not black and white. Some people have this idea that space is all black and white because really our eyes can only pick up so much detail when we're looking at it But again, when we use these cameras that can take beautiful pictures like this one, so we're back to a real picture here, you can start to see really great detail and actual color. Sometimes the color looks like really strange and you're like, is that really what that looks like? And it's because in space, in astronomy, we have different wavelengths of light. There are different types of light that our eyes can't really see. And cameras can see that light though. And we can detect that light with those cameras and visualize it in colors that we put up on the computers like this. But this is actually what we would see in visible light, what our eyes could actually pick up if we were this close to it or that close to it in real life. So again, there's this overview of this area in space here, and it's really beautiful. Is this the trapezium here, Nicolette?
I believe so, yeah.
Or actually, I think it's in here.
Yeah, I do know that the 4 stars, one of them is an O6 star. And for our viewers, that's a very hot and large star. It's going to be emitting a lot of light and a lot of energy. And the other 3 are B stars, which, believe it or not, those are not as bright or as large as O stars. You'd think it'd go in alphabetical order. It does not.
Doesn't. Yeah, so there's like all these like classifications of stars. There's different types of stars. Just like there's different types of trees here on Earth. They come in all shapes and sizes. There's lots of different types of stars. We're going to see some examples of really large stars later on. All right, so what's next? We got back to our view of Orion the Hunter in our night sky here. And let's zoom into a different location. Instead of going to the sword, let's go towards the belt. And there's another cloud of gas and dust here. Melanie, what's going on around here?
Again, there's a whole lot going on. So there's like a whole bunch of different nebulas all kind of close together. They're kind of correlated in a way and really make each other look pretty cool. But if you look really closely, you might see something that resembles the head of a horse. I think it looks more like Nessie or like Tessie in Lake Tahoe. I love a good cryptid creature, but if you can find that, you're on the right track. And this is what we call the Horsehead Nebula. I feel like it looks, I don't know, the Loch Ness Monster from that one picture.
All right, so for everyone watching, if you haven't found it yet, it's right here. It does look more like the Loch Ness Monster. It does look like a horse's head as well. You have to kind of turn your head a little bit.
Yeah.
But this clip is going to zoom in on this other area of space here. And what does this look like to some people? It kind of like this, from this angle, this view, kind of looks like a bonfire or a fire. So I think that might be where they got the name of it, right?
Yeah, the Flame Nebula.
Yeah, the Flame Nebula. Okay, so
Good name.
What was that?
It's just a good name.
It is a great name. And I think it lives up to its name, especially when we kind of zoomed in to see more detail here. So again, this is a real photo of this area. And so much detail, so much going on here. So many stars in just a small area in space. There are billions of stars in our galaxy that we can explore. And just a whole bunch right here in the Flame Nebula. I think it's beautiful. All right, so here's the Horsehead Nebula, or the Loch Ness Monster Nebula, as we're going to call it. The head here, again, it just looks like Nessie.
Mm-hmm.
Yeah, it does.
I still see the back of the horse, and the head is turning around at you. That's what I see. And I can't.
Yeah.
It.
Okay.
Yeah, it's forever imprinted into my brain.
All right, so we're going to move to a simulation here to look at our next object in Orion the Hunter. And that is a star that is called this. And people pronounce this in lots of different ways. You'll hear a lot of people pronounce it Betelgeuse. Other people will pronounce it Betelgeuse. I have looked at a lot of different sources, And a lot of them are different from one another. I think every single one of them was different in some way. But most of them say that this is pronounced more like Betelgeuse. Jooz kind of sounding at the end. So Betelgeuse here is the red star that makes up one of Orion the Hunter's shoulders. And it's red, so it must be different than some of the other stars that look white in our sky or blue in our sky. And it is. So that we learned from Nicolette that there are different classes of stars. What kind of classes do we have? We have all the letters, but then we also have other types of stars. We have dwarf stars out there. We have giant stars, supergiant. Anything else? What other stars do we have?
Hypergiants. We have
Hypergiants.
Main sequence stars.
Oh,
Main sequence.
fancy. Main sequence. When stars are forming helium in their cores out of hydrogen gas.
Yes.
We have white dwarfs.
Yes.
There are other types of dwarf stars, so like white dwarf stars and other types.
Remember that from past shows.
There are red dwarf stars. It's a really small
There are brown
reddish
dwarfs.
stars. We have brown dwarfs. There's more.
Yes.
There's neutron stars. When stars die, they can become a neutron star.
Do pulsars count as stars, or are they pulsars?
They are neutron stars, so I think so.
Pulsars are neutron stars that spin really fast and kind of send out this beam of light that looks like it's pulsing in the sky to us here on Earth. So there's pulsars, which is a
Like a
type of
lighthouse?
star. Yeah, it's like a lighthouse, yeah.
We have variable stars.
Yeah, variable stars. And Betelgeuse is a variable star, which means it changes its brightness periodically. So that's pretty cool. We have a lot that we can explore with Betelgeuse here. Let's see how big it is, though, because it's red, but we talked about like a red dwarf star, and then there's what we call red supergiant stars. So let's see how big Betelgeuse is. Let's start our simulation here. And we're going to put this in perspective of our solar system. So we were just looking down on Earth. Let's zoom out and let's see the orbit of Earth, Mercury, Venus, and Mars. And we're going to turn our sun into Betelgeuse in our simulation here. I'm going to pause it here, though. It hasn't gotten as big as it will. But I want people to make a guess, a prediction of how big do they think that this is going to get. So again, we're turning our sun into the star Betelgeuse. It's going to get really big. As you can tell, it's already getting bigger than our sun. Red dwarfs are smaller, so this must not be a red dwarf star. It's something else. Red supergiant. But how big will it get? Melanie, do you know? Do you remember?
I was gonna say, how giant is supergiant? I think maybe out to Jupiter, but definitely past Mars.
Okay. Nicolette?
I definitely agree. I was going to say that when the our sun begins to die, it's going to go into a red giant star first. It's going to expand out, and we predict that it's going to be about Mars, at Mars,
Yeah.
or slightly past that. So since this is a supergiant, I figured it's going to go past that.
Okay. And Caleb, you did a lot of research for the show tonight about Betelgeuse here, so you know the answer. So I'm going to let it play, and I'll let you take it over here.
All right.
So again, we're turning the sun into Betelgeuse. It's still growing. It's still getting there. But how big is it going to get, Caleb?
Well, as Melanie and Nicolette likely guessed, it's going to get up to about the radius of Jupiter's orbit. So that's how big how big the radius of Betelgeuse is in real life.
Yeah, so it got as big as Jupiter's orbit there. Beautiful. And it got really red too. So it's a red supergiant. And Nicolette kind of touched on this, that our sun is going to turn into a red giant when it starts to die. So Betelgeuse is at the end of its life, right, Caleb?
Yeah. Betelgeuse is in a class of stars that when they reach the end of their life, they basically expand, and Betelgeuse, because of its mass, it becomes a red supergiant. So more massive stars will become supergiants, and due to what we know about it, we estimate that it's going to basically, end in a supernova in a relatively short time. Although we must remember in astronomical units, time is a lot larger than as we experience it as humans. So when we say it will go to supernova soon, that could basically be another million years. So
Yeah, and a million years is a really long time. Um, so yeah, stars do get born. We saw stars being born in the Great Orion Nebula. We flew past some stars being created in the star systems that they're making there. But stars will die too. They'll run out of their fuel and eventually turn into things like a red giant or a red supergiant. And then after that, what's next? So after a red supergiant phase, what happens?
I believe what happens next is what's known as the supernova.
Yeah, supernova, the most energetic things we've ever seen out in space. But Betelgeuse is quite a ways away, right, Caleb? How far is it?
It's about at least 550 light years away, although it is about an estimation. It's very close compared to other objects in our galaxy. So
Yeah, there's stars in our galaxy that are many thousands of light years away. Remember, a light year is about 6 trillion miles. But there are stars that are closer, and Betelgeuse is about 500 light years away. But still far enough so that we will not feel the effects of that supernova, that massive explosion, when it does end its life or go to its next stage of life, really.
yeah,
How
you have
close
to be
do
at
you,
least 50 light years
yeah, I was just going to ask
close.
Caleb, how close do you have to be for a supernova to affect you? You said 50 light years you found?
50 light years. Yeah.
Yeah. So still a really long distance, but I'm surprised that even, you know, in 50 light years away, because that's really far, you could be affected by a supernova. That's
I know
just
we learned in
amazing.
class, Caleb, you can correct me, but we learned that like a main sequence star throughout its whole life, the amount of energy it releases is the same amount or actually less than is released during the actual supernova, which is just a fraction of a second. So over these like millions or billions of years, all the energy that it is releasing is actually less than will be released in a fraction of a second.
It's intense,
Mhm.
literally.
Yeah.
Wow.
And actually, we also learned in class that a supernova will often be brighter than its host galaxy. So
For like a
we
week.
could, for a week basically.
Hmm. Yeah,
Hell,
we
even
can see other galaxies and actually see a supernova event with telescopes, which is quite impressive. It's like impossible to see resolve basically other stars and other galaxies. They're so far away. Our telescopes really aren't that powerful. So when a star goes supernova, for us to see that point of light in a really far away galaxy, like that's amazing. All right, so we have stars that are born and stars that are going to eventually end their lives in supernova events or other types or through other means, basically. And Caleb mentioned that on long time scales, millions of years, it's really unlikely for us to see something like this in our sky. So there's some quotes and stuff on Facebook and other social media platforms, just the internet in general, that are like, you can wish on a star in the sky. It's probably not even there anymore because it's probably dead. And it takes time for light to travel from place to place. So, probability is that it's not even there anymore. But like, how realistic is that? Stars live for millions, billions, and trillions of years. So the probability of a star not being there anymore really isn't that high. And so let's put those numbers in perspective. So when we talk about millions, billions, and trillions, it's a really big number, but how does one compare to the other? Think about it in terms of seconds here. constellation crew friends. If we are thinking about 1,000,000 seconds, how long of a time do you think that is? 1,000,000 seconds. How much time is that? And if you are watching and you think you know, you can go ahead and put the answer in the chat.
I know that 3,600 seconds is important. We use it in physics all the time, but I can't remember if that's 1 year, and that's how many seconds there are. I think so. I'm pretty sure that's a year. So just a year is only 3,600 seconds. I think.
I have the number 8 in my head for some reason, like 8 years.
1,000,000 seconds.
Wait, be wrong.
I think it's a lot shorter than that. I think it's maybe a week or so.
Caleb's closer.
Yeah, and I think I was wrong, by the way. I think the 3,600 seconds is a day.
You're probably off by like a factor of 100 or so.
Yeah.
Which is fine in astronomy because that's like no big deal in astronomy.
I just want to make sure the viewers know so that they don't go,
Yeah. No, we'll get to the answer. We'll get to the answer. So 1,000,000 seconds is about 2 weeks.
Oh wow.
2 weeks. What about 1,000,000,000 seconds?
Yeah.
So 1,000,000 is 2 weeks.
It's about 2 weeks. It's not exact.
Right. Forgot how many zeros more a billion is than a million.
I know it's Friday afternoon. I can't do math anymore.
I know I'm getting tired too. It's been a long week, right?
You're thinking
1 billion.
Yeah,
okay, so 1,000,000 seconds is about 2 weeks. 1 billion seconds is about 32 years. So that's a big jump, right? How do you even imagine that? And then a trillion seconds. So this is a little bit easier. So if 1 billion seconds is 32 years, how much is a trillion?
I'm going to say 1,000,000 years.
No, remember, just do your math. So 1 billion from to a trillion.
I'm thinking 60.
200 years.
It's 1,000 different, right? So multiply it by 1,000. 32,000.
Right.
32,000 years. So 1,000,000 seconds is 2 weeks. 1 billion seconds is about 32 years, and a trillion seconds is about 32,000 years. So there's these big jumps here. And so again, stars can live for millions, billions, and trillions of years, really long times. It's really unlikely that we're going to see something die in our sky like Betelgeuse here, which is going to eventually go supernova, scientists think. Just, it's probably not going to happen in our lifetime. But there is a probability. I mean, there are billions and billions of stars out there. So stuff is going on all the time. We're seeing stars form all the time too. So you don't know. You really don't know. So we talked about Betelgeuse being a variable star, and that we kind of talked about how variable stars are periodically changing their brightness. But let's see that in this simulation here. Because Betelgeuse does this on an 11-month time scale. So you can see the months ticking by. We're speeding up time here, and you can see it kind of pulsating. It goes through these changes here. But late 2019 and early 2020, we saw Betelgeuse dim a lot more than what it periodically does here. Betelgeuse dimmed so much that it became as bright as a star next to it. So let's back up here and go and see this from our sky. So we have Betelgeuse there, that reddish star that makes up one of his shoulders. There's another star in Orion called Rigel that's opposite of Betelgeuse. Second brightest star in the constellation usually. But there's one more star here called Bellatrix, and Bellatrix makes up Orion's other shoulder. Well, Betelgeuse got as dim as the star Bellatrix. And just looking at how it normally does, or pretty normally anyway, it's quite a bit different here. And it got so dim, scientists really started talking about it. You probably saw it in the news. There's so much going on about Betelgeuse. Why is it dimming? And we actually have some really good data that was taken with great telescopes of Betelgeuse, and we can get an idea of what maybe happened to cause it to dim so much. So we shifted over from our simulated view of everything to real pictures. Not as impressive in some ways, but I think more fascinating. You get a lot of really cool detail. It's really hard to see. It's fuzzy, but like I think it's just amazing that you can even see anything to this detail that's 500 light years away. So here's the star. You can see that there's this bright area here, but there's this dim area that really told them that, hey, the star really isn't darkening all at once. Just this area of it is. So something must be happening that is making it dim just as, like just a small fraction of it basically, and not the whole thing. And what did they conclude? Do you remember, crew or Caleb? This is your item here.
I believe the conclusion was that it was dust that had been ejected from the star. That was one likely theory. That Betelgeuse is constantly losing gas, and they believe some of the gas cooled enough to basically make it appear a little dimmer, basically.
Yeah, so as the star evolves and changes, it's ejecting material and ejected this kind of dense material out into space that blocked some of the light that was being emitted from it. And you can see that here. Cool.
Do you think the actual ejection of material did make it dim a little bit, or was it just the effect of it kind of in the surrounding area?
I think it was the material itself.
Okay.
That's what I would think.
I don't know what effect it would have if it lost some mass.
I think the star bounces back pretty quick.
Okay.
If it loses some of its mass. It's just like,
A funny thing about Betelgeuse I found is that it's basically on a collision course for like a giant dust cloud in the next several thousand years.
Oh yeah, because like stars move as they are going around our Milky Way galaxy. They're just so far away we really can't see that motion in our sky. The motion that we do see is an apparent motion because Earth is spinning in space. But they are moving out in space. They're orbiting the galaxy. So yeah, they could collide with other things like a cloud of gas and dust, that nebula, like the Orion Nebula like we saw earlier. We also, when we talk about these different types of stars, we see different colors. And just a reminder for people watching, crew here, do you want to explain why we see different colors of stars?
Should I go or?
Yeah, go ahead.
All right. Well, a lot of what we see different star colors usually due to temperature. A lot of it's due to temperature because star colors usually give an idea of how hot the star basically is. Now, stars generally are really hot, but some stars are hotter than others. And a star like Betelgeuse, which is a red star, is actually one of the cooler stars that we can see. Which is kind of surprising because we usually think of red as being a really hot color.
Yeah.
But actually, some of the hottest stars are those that are actually blue or white, basically.
Yeah, it's opposite from what your faucets say at home or school or what have you. The red stars are less hot, and the blue stars out there are the most hot.
I never thought about the faucets. Have they been conditioning me this whole time to get it backwards?
Yeah, there's just like a whole bunch of weird things with color. What we like have been conditioned to, because ice kind of does have like a blue tint to it. So, ice is cold, and that's our point of view and what we experience every day. And fire is red, and it's really hot. But then when we explored other things, we found out that that's not necessarily the case for things like stars. And we don't want to change everything on Earth to match that, I guess. But it makes things confusing to some people, especially when you try to decode the information from really confusing maps about the temperature of the universe, like the cosmic microwave background radiation and all of that.
I used to freak out my elementary school teacher because whenever we would color, I would always color the lake green. And she's like, why is the lake blue? It's made out of water. It's supposed to be blue. And I said, it's only blue because water is reflective and it's reflecting the atmosphere, which is blue.
Well,
look at it. And she's like, what? She never understood what I was trying to say.
Well, there are some scientists that say that blue or water, it does actually have a blue tint to it. As the molecule, it does actually reflect some blue. You just need a large amount to actually have that. But I don't know. I think that there's a lot of things with color, a lot of different ideas out there, and people will have their own opinions and own ideas of why water is blue, honestly. But it's interesting. Okay, so speaking of colors, we're back to our view of Orion the Hunter in the sky. He's over here, if you lost him, or if you're just joining us. He's got a reddish star here for his shoulder. That means it's a red star, right? That means it's less hot than the other stars here that are blue or white-ish in the constellation. And you can actually see that color with your eyes in the real sky. All right, so we have 2 stars for his shoulders, 3 stars that make up his belt. He's got a little sword off of his belt here, and 2 stars for his feet or knees. And there's more to it. And we have an old drawing because we're going to end the program today, as we usually do, with some stories about this constellation, some of the mythology with Nicolette.
Yes. So for our regular viewers who are aware of how mythology works, you are going to understand where I'm coming from. But for the new viewers, in the world of mythology, there are a lot of stories or tales that we can tell about one character. But the same character can have different variations. So you can have multiple tales, but each tale then has a variation of its own when you go from region to region. Therefore, there are multiple different versions of one character's story. So there's a lot going on when it comes to mythology, and you'll understand what I mean by that when I get further into it. So Orion is called Orion the Hunter, as Dana has said a couple of times throughout the video. As you can see, he has a club and a little sword, or I would call it a dagger because it looks really small. But he's depicted in many different ways. Sometimes he's wearing the lion on his head, and he has a sword in his hand instead of a club. Sometimes there's no lion, and he's just standing there with a sword in his hand. But either way, he is the hunter, and he was known as one of the most handsome men in mythology. One of the myths that you can hear about Orion is he fell in love with the Pleiades, which we will be talking about in next week's episode. But they are also called the Seven Sisters in mythology. He fell in love with all of them and began to pursue them and chase them all the time.
How dramatic.
And they prayed to Zeus that they wanted help. They wanted to get away from him because he was following them everywhere. And Zeus scooped them up and put them in the sky to get away from Orion, because Orion had other stuff to do.
I think they should have put Orion in the sky instead.
Yeah, he's gonna do that. He eventually gets put there, but the irony is that you can't see it in our Orion picture, the Greek mythology or the real life star picture, but eventually when you see it next week, you'll see that the Pleiades is not too far from Orion, so it's that ironic joke that he's still chasing them in the sky, which is kind of sad because they got there to escape from him. But nonetheless, they got away from him for a little bit. Some other stories that you might have heard is Orion involving a scorpion. And again, there's many different versions of how he is involved with a scorpion. One of them is that he boasted to the goddess Artemis and his mother Leto that he could kill any beast on earth because he's Orion the Hunter. So to test him, the earth goddess heard him and sent a scorpion, which stung him to death. Another version is that he forced himself onto Artemis, hitting on her, and she did not like that, and she sent a scorpion to get him again. And the last tale that you can hear is that he was trying to save Leto from a scorpion, which still killed him. But now, if you remember our very first episode of Constellation Crew, we talked about Scorpius, right? That's the constellation name, is Scorpius. Okay. So Scorpius is by Orion as well in the night sky. So another thing is chasing Orion. So Orion is chasing the Pleiades, and the Scorpion's chasing Orion, which I find hilarious.
Sounds exhausting.
It's
Yeah.
a big chase. Yeah, because again, like everything kind of appears to move in our sky because Earth is spinning, but nothing really gets closer together from what we can see night after night. So yeah, if Orion and Scorpius are on opposite sides of the sky, they're always going to be on opposite sides of the sky. Unless we go to like another star system and see space from a different location, we'll have like whole new constellations and we'll have to make up all these new stories for them. We won't have the ones we're familiar with. Why does Orion have this kind of reddish tint to his cheek? Is that just an
Maybe that's
artistic?
Betelgeuse.
No, Betelgeuse is over here.
I believe that's supposed to be a star, and I don't want to get too close to the camera for our viewers because I can't see, but it looks like there's an M there. It looks like Matilda to me, but I don't think there's a star named Matilda.
There's some stars here, but I don't know, it looks a little red. But they also kind of put like this really intense red on the lion's lips. It kind of looks like lipstick. So
Yeah.
I think it's just the drawing, beautiful drawing, an ancient drawing. But in it, you can see that there are other constellations here that border Orion the Hunter, like this one up here, that's Taurus, and that's where Pleiades is, the star cluster that Nicolette was talking about. So we're going to be exploring Taurus next week, and we're going to learn all about Pleiades, see some great pictures of it, and more. So you're going to have to come back for that. Before we wrap up today, friends, Melanie, Nicolette, Caleb, do you have anything else to add?
Not that I can think
I
of.
was gonna say, who appears if you say Betelgeuse 3 times in a row? I don't want to.
Oh, I don't want him in my dorm room.
I think there has been like or there was when they were making the movie Betelgeuse. I think that it was spelled Betelgeuse, like the way the star is. I think it was spelled that originally. I might be remembering that wrong, but I think that was like one of the little fun facts about that movie. And I think they changed it because they're like, no one's gonna know how to find that movie or remember that movie, so we have to rename it.
Who are you gonna call? Betelgeuse.
No.
Well, I mean, you can Bete, isn't it? The first part of it.
Mm-hmm.
I'm a terrible speller, so I could be wrong.
It's spelled different in this picture even. So maybe that might be some of the confusion. I didn't notice that, but it's Betelgeue. Can't really make it out. It looks like it ends with an X here. So it might have a different spelling down the line somewhere. What's I think is more important than how to pronounce something or how to spell something is the information about it. And Betelgeuse looks red in your sky. Go check it out. Sometimes it changes its brightness, or it does change its brightness over an 11-month time scale. Sometimes it gets even dimmer than what it periodically does. And you can see that in your sky. So check it out. Orion's left or eastern star for his shoulder. All right. Anything else?
I have to say that this is one of my favorite constellations because it's such an interesting, show of like different stars in different periods of their lives. I mean, you have Betelgeuse with being almost at the end of its life, and you have new stars being formed by the belt.
Yeah,
so,
we have new stars here in Orion, in the Great Orion Nebula down here. And then we have Betelgeuse, which is a red supergiant that's going to go supernova eventually. So we have life, and like birth and death, all in the same episode here tonight. We're very dramatic, and we have some stories with Orion. So there's so much going on here. And one of my favorite things about Orion is that you can use him to help you find many other things in the sky. That's why we're starting with him as we continue our Constellation Crew programs this semester. Because with Orion's belt, you can find Taurus the Bull, that Pleiades star cluster, and so much more. So we're going to come back to Orion. We're not done with him yet. So check us out next week. All right. Until then, have a great rest of your evening, a wonderful weekend, and stay safe, everyone. Take care.